In this video, we're going to go over radicals. So the way I teach radicals, I think of radicals as people dating. So all my examples here are going to be dating examples. So first, we're going to have to figure out how to simplify radicals. And so radicals are big on the SAT in terms of being able to simplify them in the most simplest answers. So I think of radicals like this. I think of this as a house. I think of this as the kind of like the number inside the house, and I think of this as kind of like, so let's go ahead and simplify this one. So I always use a tree method. So it's going to be 14 and 2. It's two numbers multiplied to get to 28, and I think of 2 and then 7. And so in terms of dating, you usually have only two people dating. So I look at the ones that are similar. So people who are similar like to date. So I know those two are the same. So it being simplified is that this goes to the outside, and it becomes a 2 because people who are similar like to go out and date, and the 7 is a single one, so it stays inside the house. So let's practice another one. Let's do 80. So from here it's 8, 10, 2, 5, 4, 2, 2, 2. So you got this one, you got this one, and then this is a single one. So how it works is that since we have two of them that are going out to date, they actually just multiply with one another. So 2 times 2 is 4, and the single one is 5, so it stays inside the house. The next one, let's try 150. So this one's 15, 10, 2, 5, 3, 5. So I know that these two date, and I know that these two are the single ones, so the 5s go out and date. And what happens with the 3 and the 2, they actually multiply. So 3 times 2 is 6. So it would be 5 square root of 6. Now, what happens if we have it something like this? Instead of being a square root, it's a cube root. So with this one, we do the same thing. We do 8 and 5. We do 2 and 4. We do 2 and 2. So from right here, instead of two people dating, think of this as a three-way date. Yeah, it's kind of strange, right? It's three people dating. Think of like kind of the weird hippies. So we got this right here. And if they go out and date, there's a 2 right here, and then this 5 right here, the single, so the answer would be 2 root 5. And it'll look like that. And that would be it in the most simplest form. So with this one, we're adding and subtracting radicals. So how this one works is that, let's say we have this. Root 2 plus root 3. So what do you think that answer is? Well, the answer is, this is actually the answer. They actually can't simplify. So the adding and subtracting radicals, they actually have to have the same base for them to add. So for example, let's say I have 4 root 3 plus 5 root 3 minus 4 root second. So for them to add, these bases actually have to be the same. So I know these two bases are the same, so they add. So we're going to take the outside numbers, and then we're going to add them. So 4 plus 5 is 9. We keep the base the same. And then this right here, there's no bases that are the same, so we keep it like this. So let's do another problem. Let's say we have 8 root 6 minus 8 root 2 minus 5 root 6. So for this one, I notice these two bases are the same. So it's going to be 3 root 6 minus 8 root second. And those are the rules for adding and subtracting radicals, is that for them to add or subtract, the bases need to be the same. Let's go over multiplying and dividing radicals. So let's say I have 5 root 7 plus 3 root 2. So with these, I think of them like this. These are called outside the house. These are called inside the house. So I think of it like this. Extroverts date extroverts. Introverts date introverts. So 5 times 3 is 15. Root 7 times 2 is 14. So that's how you multiply. So let's do another example. Let's say we have 6 root 8 times 2 root 3. So same thing, extroverts date extroverts. 6 times 2 is 12. Introverts date introverts. 8 times 3 is 24. So then that would be your answer. So dividing radicals, the idea is actually the same. So let's go ahead and practice a problem. So 8 root 6 divided by this. So what it looks like is 8 divided by 2 is 4. So these two divide, and then these two divide. So square root of 6 divided by square root of 3 is going to be 2. So then your answer would be 4 root 2. Let's do one more example. Let's say we have 2 root 10, 20, and then 40. So from here, they don't actually divide, but they can reduce. So 2 over 10 reduced would be 1 over 5. And then from here, what it looks like is that 20 and 40 can't divide, but they can reduce. So 20 and 40, they reduce to 1 over 20. And then the square root of 1 is the same thing as 1. So 1 times 1 is 1. And then it would be 5 square root of 20. So the rules for multiplying and dividing radicals is extroverts date extroverts, introverts date introverts, and then that's how they can multiply or divide. The next one is that we're going to convert exponent fractions to radicals and vice versa. So let's say we have x to the 1/2, and we want to convert it to exponent form. What it looks like is, it actually looks like this. This gets kind of confusing because there's technically an imaginary 1 right here, and there's technically an imaginary 2 right there. So whatever on top goes right here, and whatever goes on bottom actually goes right there. So let's take a look at another example. Let's say we have 7 and then 3/4. So if we want to convert it to radical form, it looks like this. 7, 3, and there's technically a 4 right here. So this 3 goes right here, this 4 goes on the outside. So let's say we have it the other way around. Let's say we have x 3 like this. If we want to convert it the other way around, it's going to be x to the 3 over 2. So remember, whatever's here goes on top. There's technically an imaginary 2 right here, and it goes on bottom. So let's look at the other one. So let's say we have 4, 8, 3. So from here, it's going to be 8. It's going to be 3 over 4. So this 3 goes on top, this 4 goes on bottom. So as you can see, the trick to converting exponent fractions to radicals is that they essentially, whatever's on top goes in the radical, whatever's on bottom goes to the square root.